Hey guys, I'm Penny, this is Fraser, and this is the Level 3 Organic Strategy video.
This standard is broken into a few key parts. We got naming, isomers, melting points, boiling points and solubility, esters, reactions, and polymers.
While you can expect specific questions in all these areas, expect questions on reactions and naming to pop out throughout the paper.
So reactions is the big thing that people freak out about organic chemistry. They think it's all about memorization. They have to remember 200 different statements about like alcohols and PCl3 going to haloalkanes, but it doesn't have to be like that. Humans don't really think well when you have these big outlined, reaction flow charts that take up a whole page. Humans think really well in lists. So it's really a good idea to organize your thinking in sort of a list way. And the way to do that for organic chemistry, in my opinion, is to do that with types of reaction. So there are 5 types of reaction you need to know at Level 3 Organics. There's addition, elimination, oxidation, reduction, and substitution. So if you go through and learn a bit about each of this different type of reaction, then you can, whenever you're confronted with a reaction, you can, cross it off the list. So for example, addition reactions, you break a carbon-carbon double bond. Elimination, you form a carbon-carbon double bond using sulfuric acid or KOH alcoholic. Oxidation uses permanganate or dichromate. Reduction uses NABH4 and reduces the number of bonds to oxygen, and substitution is all about swapping. Obviously this is just a very brief overview of that thought process. Definitely go ahead and check out the StudyTime Level 3 Organic walkthrough guide, because that details this process a lot more in depth.
There's very likely going to be a question on esters in the exam, and I have some good news for you. It's pretty much the same from year to year. All you can do with esters is make them or break them. To make an ester, you need a carboxylic acid and an alcohol, a little bit of acid as a catalyst, and some heat. Don't forget that water goes off as a byproduct. To break them down, in both cases you always need water. However, there's 2 different types of hydrolysis. There's an acid hydrolysis and a basic hydrolysis. In acid hydrolysis, you end up with the same alcohol and the same carboxylic acid. However, in basic hydrolysis, you end up with the same alcohol again, however, you get a carboxylate ion, and that's essentially just the conjugate base of the carboxylic acid.
Just like the esters question, it's very common to get a question on enantiomers in Level 3 Organics. So the first thing that you need to know about enantiomers is how to identify the chiral carbon, and that's just the carbon with 4 different groups attached. Then you need to know how to draw the enantiomers in 3D, like this. And basically, enantiomers are just mirror images of each other. Then the last thing you need to know is you need to say how you can tell enantiomers apart. And for this, you can just throw out this sentence. Enantiomers rotate plane polarized light in different directions. Don't need to understand what's going on, don't need to understand what that is. You can just write that and you will get the marks.
Another common question that you're going to get is on reflux versus distillation. It's important to be able to understand the different apparatus between the 2 processes and to be able to pick them out of a lineup. It's also important to understand what happens to a primary alcohol when you react it, how it goes into an aldehyde and then a carboxylic acid. In distillation, you're going to be separating different compounds based on boiling points. So when we have alcohol and we react it, the aldehyde evaporates and it's then condensed out into a separate vesicle, so you're able to separate that aldehyde. In reflux, you evaporate it and it's condensed back down into the same vesicle. So then the aldehyde reacts again into a carboxylic acid. This way you're able to react the alcohol completely into a carboxylic acid.
Overall, everything comes down to naming and reactions. These won't be localized to specific questions like esters or polymers, so it's really important to have this and know that they're going to come up throughout the whole paper.
While we've covered some important strategies, note that we haven't quite covered everything. It's important for you guys to do at least 3 to 4 exam papers. Check out the StudyTime walkthrough guides and our checklists so you can be better prepared for the exams.
Thanks for watching and good luck in your organic chemistry exam.